Good morning, all. So I think again we came back for online classes. Yeah. So anyway, I think this would be the better thing where at least students, those who are attending. So those who are not able to attend, they can also view these classes through my YouTube channel, because I'm gonna upload every video in my YouTube channel, so where you can access and you can go through the classes, right? Guys, and I request all, so please inform your friends also, right? So we're going to continue this online classes till the summer vacation ends, and this might be the effective way to teach. So why? Because you guys are not attending classes regularly, so I think this would be the better one. Okay, right. So I think in the fourth module we are supposed to discuss the two more topics. One is the pipe culverts and the other one is the box culverts, isn't it? So today we are going to discuss about the pipe culvert. Okay, so first we will go into the theory, how the pipe culverts are going to be defined, and how many different types of pipe culverts, what are the design categories, everything we will discuss it today. Okay. Yeah. Guys, is screen visible? Andarki screen kanpistunda? Pipe culverts. Guys, please respond. Is the screen is visible?
Yes, sir.
Okay, very good.
Sir, visible.
Okay, right, yeah. Yeah. See, first of all, let's go to the brief introduction about the pipe culvert. So this is the picture how the pipe culvert looks like. Here there are few important points where we are supposed to note down. Okay, and I request all of you, so please follow the running notes, write down the notes wherever you feel which is important. Okay, right. See, whenever the cross drainage flows on a relatively flat terrain with no well-defined channel or gauge, and if the discharge is limited, so that means, for example, if there is any water which is flowing at the road level, okay, for example, if you are crossing a road, if you are moving on a road, so for example, a water which is crossing the road at the road level, okay, for that to to cross that water, so you are supposed to construct a structure. Okay, so at the flat terrain levels, okay, without defining a well-defined channel, okay, so if you want to construct any structure, means, so that structure would be the pipe culvert. Understand? So for example, just I will draw it here, and I will try to show it down clearly. So let us consider this is your road. Okay, this is your road, and the water which is flowing like this, okay, at the road level itself. So let us consider the road level and the water level will be almost the same. Okay, so here you need to understand very important point. Well defined, so not so well defined channel. What do you mean, what so well defined channel? So usually, what about the channels? See, for example, if you see the major canals, minor canals and all, so they all will be defined clearly like this. All channels will have a predefined depth and predefined slopes. But for this what we call culverts, okay, for this water will be regular. This water might have the straight path. The water may come like this with an inclined path also. So where your road will be like this, okay, water will flow in this way also. Understand? So this is how there is no well-defined channel shape. So where you are going to construct the pipe culverts, so which will be the best choice to cross this particular water flow. Okay, so where you are going to construct the pipe culverts at this point. So at present, basically RCC pipe culverts, and in owing to a negligible maintenance cost and ease of large scale production of quality pipes using the spinning process. See, nowadays they are going to use RCC pipes. So this is the pipe. So this is pipe which is completely an RCC pipe. RCC means reinforced cement concrete pipe. So inside there will be reinforced rods. Okay, so like this rods untai, and it will be casted on its circumference with concrete. Understand? That is what about RCC pipes, right? Yeah. And a pipe culvert usually consists essentially of a pipe barrel. Nothing but this is what a pipe barrel. Okay, so we call this as a pipe barrel. And so basically your pipe culverts are going to be two types of pipe culverts untayamma. One is pipe culvert for high embankments and pipe culverts for low embankments. Okay, please try to note down this, very, very important. So there are two types of pipe culverts. One is high embankment pipe culverts and low embankment pipe culverts. Okay, what do you mean high embankment pipe culverts and low embankment pipe culverts? What do you mean that? Ante, so let us consider this is your road. Okay, and this is your embankment. Okay, this is completely embankment. So where vehicle is passing here, vehicle is going there. If the pipe culvert is positioned here, this is your pipe culvert. Okay, so this is called high embankment pipe culvert under. And the road level and the pipe level will be at very high level, very high in levels. So this is called high embankment pipe culverts. Okay, so if the road level and the pipe culvert level is almost same, okay, within the road level, so these are called low embankment pipe culverts. Understand? So this is how there are two types of pipe culverts. One is high embankment pipe culverts and low embankment pipe culverts. Understand? So in case of high embankment pipe culverts, there will be minimum protection works are built allowing the embankment to stand within the natural slopes. Obviously, what happens, for example, if this is a very high embankment, why? Because see the depth of the embankment from the top of the pipe is too much. And this is the slope which you are maintaining for the embankment. Obviously, this embankment is supposed to be pitched properly, isn't it? Avuna? So this embankment is supposed to be, see, completely this embankment is supposed to be pitched properly. Otherwise, what happens? There will be soil erosion takes place. Why? Because your road level is very high from the bottom ground level. Okay, so where you are maintaining a huge slope, so you have to do lot of slope protection works cheyali. Okay, we call them as slope protection works. Understand? You have to go through the slope protection works. Why? Because there is a high embankment where the slope of the bed is the natural slope is too high. Understand? On the other hand, low embankment pipe culverts will have two head walls. Obviously, what do you mean two head walls? This is wall. So if you see the picture which is shown in the document, okay, so you can understand it clearly. So this is one head wall and this is another head wall. Okay, for low beds, okay, for the low embankment pipe culverts, there will be two head walls. This is one head wall and this is another head wall. Okay, so which is provided on either side of the embankment. Okay, so to control what? To control the slope. So this is what the slope. To control this slope, these embankments are enough. Understand? So this is what the slope, down slope. Okay, so this is how the schematic diagram represents the pipe culvert which is at the road level. See, you can see clearly this is the road and the pipe culvert is also on the level of the road. Okay, so at the low embankment pipe culverts, the head walls are enough, but for the high level embankments, you have to go with the minimum protection works for the embankment. Understand? This is how the pipe culverts are defined clearly. Okay. Right? So see this picture, clearly it is defining. This is the head walls and these two are handrails and this is the road level and this is what the low level of embankment height. Okay, right. See, this is the next picture which I would like to show. High embankment. Understand? See, high embankment, this is the road level. Vehicles will which move on at this level. Okay, guys. See, this is the road level. Vehicle will move from here. So this is what the slope, down slope. See, you can see how height, the slope was made, because usually it's all based on the road alignment. If you see our outer ring road, all outer ring roads are above the normal road levels. Why? Because the road level itself is too high. Okay, there if you want to construct any pipe culvert, that means to pass water from one end to other end, you have to go with the high embankment pipe culverts. Okay, so here also you're going to use pipe as a culvert, but the thing is you have to go with high embankment pipe culvert. Okay, so these two are heads. These two are called head walls. Understand? So this is the RCC work which we are protecting the pipe culvert. Okay, with the because of the heavy soil on the top of the pipe. So only on the pipe there is a huge soil which is placed, isn't it? So the pipe should not get damaged because of the pipe. So because of the soil pressure. So that is the reason why you are going to construct an RCC wall on the top of the pipe culvert throughout its length. Okay, so ila complete ka construct chestar to the other end, till the other end of the embankment. Understand? So this is what about the high level embankment pipe culvert. Clear, guys? Understand? See, మీకు ఇది అర్థమైంది అంటే then we can able to discuss about other patterns in the pipe culverts. Guys, please respond. You all understood about the pipe culvert?
Sir, yes, sir.
Very good. Right. Okay. So now let's continue with the flow patterns in the pipe culvert. What is this? So this is called different types of the flow patterns. Okay. So here, don't worry, all these tables, I will give the printout for the examination, because these tables are very important to understand the flow patterns. What do you mean flow pattern? What do you mean flow pattern? Because if you see the water flow, okay, when you are crossing any road, I mean when you are moving on a road, so if you see the water flow, sometimes your water flow will be like this, okay, which is horizontal and perpendicular to the road level, perpendicular to the road alignment. So sometimes water will flow like this, where road will be like this, so which is somewhat inclined. Okay, so sometimes water will flow like this. Okay, so where you have to construct road here, isn't it? So this is the different patterns of the flow, I mean different patterns of the water flow. Okay, so this is all going to be very important to define, okay, the size of the pipe along with the diameter of the pipe and the way of head walls which are going to be constructed beside the pipe culvert. Understand? So if you read out the statement clearly here, it is a natural that the culvert acts as a construction and creates a backwater effect to the approach flow, isn't it? So causing a pondage of water above the culvert entrance. The flow within the barrel itself may have a free surface with the subcritical or supercritical flow conditions depending on the length, roughness, gradient, and upstream and downstream water levels of the culvert. See, very important. So please note down these, which are very important. Okay, so the flow of the barrel pipe itself will be free surface with subcritical and supercritical flow, which it depends on what? It depends on the length of the pipe, it depends on the roughness, it depends on the gradient, it depends on the upstream and downstream of the water levels of the culvert. Okay, what do you mean that? See, for example, this is the natural water stream which is flowing. Suddenly if you are constructing a road across the flow, okay, across the flow, what happens if you construct a road across the flow? What happens? See, a flow of water, suddenly you have constructed a road here at some elevated height. What happens? What happens? Guys, you have to answer. See, there is a natural stream where water is flowing. Suddenly, if you have constructed a road, or simple example, see, this is your movie cinema theater gate. Okay, there is only a small opening here, right? Okay, so everyone is trying to get into the cinema theater. Okay, so when movie gate released, I mean, when they open the gate, what happens? All people will accumulate here, isn't it? Yes or no? So this is only the path to enter into the cinema hall. But if you see the crowd, this crowd will be huge at this location. There won't be any natural flow like this. Okay, the complete flow will be distributed and it will create like a pond. Yes or no? Kada? The same way, okay, so if you are obstructing a natural stream where you are constructing a road, it will create a pondage of water at the near location. This location దగ్గర ఒక చిన్న pond create అవుతుంది. Why? Because you are disturbing the natural flow of water by constructing a road across the flow, right? So this create the pondage of water about the culvert entrance. This culvert entrance degra, it will create a pond. Understand? Here there won't be any pond. The water will flow freely because this is the downstream line and this is the upstream area. Okay, possibly downstream there will be a small pond where water will store until. Okay, so here because of the obstruction there will be a possibility for the pondage of water. Understand? So this all, why it happens, this all depends on the length, roughness, gradient, and upstream and downstream water levels of the culvert. If the upstream and downstream levels are, you know, as per the gravity, so definitely water will try to flow easily. If the level is not properly maintained, what happens? There will be possibility to create a pond of water. Understand? So the flow pattern of the water is also very, very important. So the various flow types which is going to be exist at the pipe barrels, we will try to discuss it here. Understand? What are the different types of the flow patterns? Let us see one by one. Okay, so see here, height is nothing but height of the embankment, D is nothing but external diameter of the pipe. Okay, so let us consider this is your flow pattern in the barrel of culvert. Okay, so what do you mean barrel of culvert? What do you mean barrel of culvert? So this is the road level. Okay, this is the road level where vehicle will move on this, and you are constructing a pipe culvert at this place, which is nothing but the high level embankment pipe culvert. So this is the water level. Okay, this is what the barrel in the sense the water which is flowing inside the pipe culvert. So this is the original height of the water. This water will try to enter inside the pipe culvert, and this is D. What do you mean D, Amma? What do you mean D? D is nothing but external diameter of the pipe. So this is the diameter of the pipe culvert which we are maintaining. Okay, and what is high H? Which is nothing but height of the embankment. Okay, from the ground level. And Y1 is the entrance of the pipe culvert, and Y2 is the exit of the pipe culvert. And this is the top flow line. Clear? Okay, so this is how the flow pattern in the barrel of the pipe culvert taking place. So here you have to understand what is H and what is D, and how the water is flowing from height to pipe culvert in depth. Okay, understand? Right. So now let's see about the culvert alignment. So here basically culvert alignment, in the sense to minimize the head losses, it is necessary that the barrel, nothing but the barrel portion follows the natural drainage alignment and its gradient. So such as arrangements may lead to long skew culvert, which will require more complex head walls and end walls. However, it is sometimes more economical to place the culvert perpendicular to highway with certain acceptable changes in the channel alignment. What do you mean that? What this statement is talking about? Let us say, for example, this is your flow of water. If you want to construct a road, try to construct road perpendicular to the stream where the water can easily flow to the other end without disturbing its way, without disturbing its alignment, original alignment. Okay, understand? For example, this is your road, this is your waterway. You are constructing the road like this. Okay, so definitely what happens, you are going to construct a pipe culvert with the skew. Ila construct cheyali. Here if you see the pipe culvert, you can construct just perpendicular to water flow, but here you have to construct the pipe culvert which is with some angle theta. So this is called a skew ante inclined anamata. Understand? Okay, where the water will again flow in this pattern. Okay, so maximum try to avoid this. Maximum, if there is no possibility, go with it, no issue. But maximum try to construct a road which is perpendicular to the flow line. Okay, which is going to be more economical. Okay, this is going to be cost. This is going to be uneconomical. Why? Because constructing a bridge in skew is not that effective and not that economical. So that is the reason why culvert alignment, maximum try to make culvert which is perpendicular to the flow pattern. I mean, the pipe should always be parallel to the flow pattern. Okay, here if you see, the water flow and the pipe is not parallel to each other. So there is with some angle. Kada ila vachi ila veltundi water. Yes or no? Yes or no? Guys, vintunnara?
Yes, sir.
Right? Are you all understanding? Andarki ardhamavutunda clear ga?
Yes, sir.
Yes? Okay. So that is what the statement is explaining. So arranging may lead to long skew culvert, which will require more complex head walls and end walls. Okay, here you need to have more complex head walls and end walls where you are going to have a skew culvert. Okay, so sometimes more economical to place the culvert perpendicular to the highway. If you go with this condition, okay, so you can have a economical culvert. Okay, which is more acceptable. Certain acceptable changes in the channel alignment chesi, you can able to construct a road or a pipe which is parallel to the flow pattern. Okay, so this is more economical. Try to go with this whenever you design any pipe culverts. Okay, for the road. Understand? Right. So let us now see what are the different types of culvert entrance structures. Culvert entrance structures. See, to prevent erosion of the bank. What do you mean to prevent erosion of the bank? So this is the road. Okay, this is the road. Annitki road level idi. Okay, because below the road only you will find the pipe, isn't it? Right. So to prevent erosion of the banks and to improve the hydraulic characteristics of the culvert, the various types of recommended entrance structures, nothing but end walls and wing walls are shown in figure. So in this picture, you can able to see different types of culvert entrance structures in Michodachu. So now see, this is the road and this is the stream which is perpendicular to the road. So here, no need to construct any walls. Why? Because this water will try to flow straight to the pipe without eroding any soil on either side of the culvert. Kada ee soil em erode cheyadu. So here there is no need of any walls. Okay, so only straight end wall saripotundi. So this is called a straight end wall pipe culvert. Understand? See the second picture. Here the stream is not parallel to the pipe. Here the stream is having with some angle. Okay, here water stream ila undi, ila flow avutundi water. So what happens, this water will try to pull the soil which is provided, which is there here. This is what the natural slope of the soil. So because of this flow, the soil will try to erode. So to control this erosion, you have to construct a wall here, right? So this is going to call as an L end wall under. It all depends on the stream axis, flow pattern of the stream. Okay, so to control the erosion of the soil at the bank, this is the bank place. Banks ante telusu kada andarki. What do you mean bank in Telugu? Telugulo emantaramba banks ni? Emantaru Telugulo banks ni? Evarna answer cheyandi. What do you call banks in Telugu? Oddu. Avuna? Guys, you are not responding.
Yes, sir.
Right. See, this banks is nothing but, so the soil which is, on either side of the flow, right? So, e banks anedi erode chances unde. So, that is the reason why, you have to provide an L end wall like this. And see the third one, which is U end wall. Okay. So, why you are providing U end wall here? Why? Because might be the stream here, the water which is flowing here will have a more velocity. Okay, more velocity in the sense the stream itself is something like a flood stream ankondi. Water will flow with more velocity. Alantapudu emoutundi, near the banks the soil will get eroded. So that is the reason why you will construct U end wall. Okay, U shape end wall. Ee vidhanga construct chestaru wall ni. Avoid high entrance losses. This is the entrance of the pipe. So to control the erosion of banks at the entrances, okay, or avoid high entrance losses, you are going to construct a U end wall, right? And the last one is flared wing wall. The wall which is not in U shape, which is with some angle around. Okay, stream will be like this. Again, so the splay which you are providing here, which is less than 1:2, and 1:2 slope lo provide chestar for subcritical flows. 1:2, which is greater than 1:2 in subcritical, supercritical flow and subcritical flow. I think you all know about this in hydraulics. What do you mean steady flow, uniform flow, subcritical flow, supercritical flow? Kada, right? So here also based on the flow. Okay, so the wall is going to be designed. Okay, for subcritical and supercritical flows, based on the slope, based on the splay slope, okay, you are going to construct the flared wing wall. Why you are going to construct the flared wing wall? To avoid vortex action. Okay, so here why we are providing U end wall? To avoid high entrance losses. Here to avoid vortex losses. Okay, what do you mean vortex losses? Vortex losses ante? Vortex ante, see, because of the stream flow, whenever the water is flowing with more dia, suddenly when it is reducing to the less dia, here the velocity will be very more. Velocity is high. Kada? Here the velocity is high. So at the high velocities, what happens? There is a possibility of vortex. La vortex form a chances untai. So to control this vortex, 1 second, amma. Sir, class lo unnanu cheppandi, class lo unnanu cheppandi. Teesta, right. Okay, so at this high velocities there is a possibility of vortexes. So to control these vortices, you are supposed to construct a wall which is like a flared wing wall. Okay, guys, right? So please try to understand all these 4 end walls clearly. One is straight end wall, L end wall, U end wall, and flared wing wall. Okay, so based on the design parameters, based on the hydraulic properties of the water, you have to design your culvert. Okay, and you have to opt any one of these 4. Okay, when you are designing the real pipe culverts. Understand? This is about the culvert entrance structures. Guys, అందరికి అర్థమైందా? Clear? Guys, respond. Are you all clear?
Yes, sir.
Okay, once again, let me take the attendance because they are asking. Okay, so that is what about culvert entrance structures. Okay, right. So now let's see about what is the hydraulic design of pipe culvert. How to design pipe culvert based on the hydraulic information. Okay, so now you tell me on what based the pipe culverts are going to be designed. On what purpose? You know, what is the main property that pipe culverts are going to be designed? On what based? How you are going to fix the diameter of the pipe? How you are going to fix the thickness of the pipe? On what base you are going to provide the reinforcement in the pipe? For all these, what is the main property required?
Discharge pressure.
Very good, very good. Discharge. Okay, so you need pressure kaadu discharge. Okay, so discharge is very, very important, right? So based on the discharge, you are going to know the dimensions of the pipe. Then how to calculate the discharge? Okay, so nothing but this is what about the hydraulic design of pipe culvert. Okay, so here it is very clear. The hydraulic design of a pipe culvert, which is going to be involved working out the number of pipes. Okay, so this hydraulic information will first talks about how many number of pipes required, okay, to pass water from one end to other end, and nothing but to pass water from upstream to downstream. Okay, first you are going to decide this number of pipes required and their size. Size is nothing but what? Diameter. Okay, these two are very important. Okay, so hydraulic design, hydraulic information endukama manaki this hydraulic design information is required to know the number of pipes required and to decide the what is the size of the pipe and the diameter of the pipe required to pass the given discharge can be found by trial and error process. How you are going to decide the diameter of the pipe? It is based on the trial and error process. And let's see what do you mean that. So here pipe culverts are assumed to flow water, to flow full with sufficient head causing flow. So the difference between the upstream water level and the downstream water level is going to be taken as the head. Okay, why? Because what do you mean head here? The water which is flowing from upstream. So let us take, this is the depth of the water. Okay, right? So let us say this is the head H1 and let us say this is the H2. Do you think the H1 and H2 will be same? Upstream of the water and downstream of the water heads will be same, huh? Rendu same untaya? Or H1 is
No,
greater than H2, H1 is less than H2. Which statement is right? Chapandi? Which is the correct one? H1 is greater than H2, H1 equal to H2, H1 less than H2.
H1 greater than H2.
Very good. H1 always will be greater than H2. Okay, why? Because here water is trying to enter with more in height, but the downstream water will go with less in height. Okay, so the difference in heads will be there. So by that the pipe culverts are assumed to flow full with sufficient head causing law. the difference between the upstream water level and downstream water level is going to be taken as the head. So the discharge through the pipe is going to be taken with the